Okay, Divya, you've asked a question here about this problem. A pump motor is used to deliver water at a certain rate from a given pipe. To obtain n times the water from the same pipe in the same time, by what amount the power of the motor should be increased? And we've got a few options here. So let's take a look at it. We have to ask ourselves a few questions to begin with. Yeah, something is changing, but not everything will change. Yeah? So what is remaining the same and what changes when we increase the flow rate by a factor of n? So we can assume the water to be incompressible. What that means is that the density is remaining constant. So that's not going to change. Also, we've been told it's the same pipe, and so the cross-sectional area through which the water is flowing is also going to remain constant. So let's consider the first case. We assume that the speed of the water in the pipe is some v, and so that gives us directly that the volume flow rate, d capital V by dt, is a into v, and this gives us a mass flow rate also. So dm by dt is rho times the volume flow rate, so that comes out to be rho av. And now we are in a position to say what happens when we increase the volume flow rate to n times. Obviously, that means that the speed of the water has also increased n times. That gives us the volume flow rate to have increased by n times, so that comes out to be NAV. Also, the mass flow rate will increase by n times, and so that turns out to be N rho AV. So we have to ask ourselves now, what is happening during this process? Now, initially the water would probably be in a sump. It is not moving, and then the pump makes the water move. Yeah. So what's happening is the pump is doing work on the water and increasing its kinetic energy. All right. So we'll assume that the pipe is horizontal. Yeah, and what that means is that there is no potential energy change from one end of the pipe to the other. So now we can use work energy theorem and say that the work done is simply the change in kinetic energy. And then we want a power. So power is dW by dt, and we get that to be the rate at which the kinetic energy is changing. Now you have to put all this together, and you should be able to get the right answer. Ask me any questions if you still have any of them. Yeah.